for design of beam, you need first to design your beam to think what is the relationship between unsupported lengths to avoid lateral torsion buckling. What is the relation between this length? You need to read your problem carefully, and the value of LP. LP, you can get it from a table. Table design of beam. Open it, related to your cross section. You can figure out what is the value of LP. Go ahead and determine what is the relation between this term and this term. If your unsupported length less than or equal this value, your nominal design moment for this beam equal F yield times ZX. ZX is a plastic section modulus. You can get it from the same table, design of your beam. Or you can get it directly. You can get this value times this value times phi directly from the same table also. So our design philosophy, your ultimate moment from structure analysis, from factor the load, must be smaller than or equal this one. So your problem may be something like this. Hey, we have a beam, your beam, we have surface dead load, we have surface life load, and we have cross section. Can you tell me, is this cross section is sufficient enough for this load or not? And also, read your problem carefully. It supports reinforced concrete floor slab that provide continuous lateral support. Continuous lateral supports mean this term LB equals 0. Every single inch is supported by reinforced concrete slab for your beam. So we don't have unsupported lengths. So we are in this case.
Dr. Amen?
Yeah.
So whenever we do when we compare it to, can we just say that the side girts that we put on there, can we make it where LB for our column, can we make sure that it's less than our LP?
Yeah. This is another for compression flange of your column, of your beam, or anything. I need to be in this case, LB smaller than or equal LB. So try to do something to make this relationship is valid. Maybe put supports, put beside girts, put Berlin, put anything with spacing that ensure this relationship. The second case, your unsupported length LB is greater than this value and smaller than the second value. This second value, but also you can get it from a table, the same table. So if this relationship is valid, we have three scenarios. You can use one of them. This equation, or this one, I prefer this one, or using a chart. Not all the cross section are available in your chart. So I prefer to use this equation. Can tell you what is the design bending strength of your beam directly. Equal CB phi times MP minus phi PF times LB minus LP. All of these factors, you can get it from the same table design of beam. But be sure you are in this category. Your LB greater than LP and smaller than LR. To get your CB, if you cannot figure out what is the value of CB, assume it 1. If it's given in your problem, that's all. If not, go ahead and open this table from your notes and try to figure out what is the type of your load. Is it concentrated load, 2 concentrated, 3 concentrated, or distributed? If it's distributed load, your support, your lateral support for your flange from at the top, at the end, and the two ends only, your CB equal 1.14. If you have intermediate support, 1.3. If you have many intermediate support, so we have different value. I will use which one?
No.
Smaller one, yes. I will use the smaller one because the smaller one will give me the smaller design value. So I am safe for this one, this part, and more safe for the other parts. Any question? Any question? Yeah, go ahead.
On example 4,
Example 4.
yes,
Yeah. This for shear.
yes, Harbinger, B1 and BN. Oh, well, it's on all the work and stuff.
For this one,
Yes.
for shear design, we have only one equation. Vn nominal shear strength equal 0.6 F yield time area web. To get your design shear strength, phi Vn. Phi assume it by 1.
Okay.
That's all.
Those are just in
We have different equation to get your phi, but to make it more simple, take phi equal 1. I think the most important part in this equation, in this problems, how to solve or how to draw your shear force diagram. If you have something like this, maybe you go ahead and open RISA and put your load in your beam and get your shear force diagram. That's fine. I don't care. Also, for the previous problems, if you have issue to determine what is the M ultimate due to the given load, dead load, and live load, after multiply this one by 1.2, 1.6, go ahead and draw your bending moment diagram. But for this one, it's very simple. Simply supported beam was distributed, your moment WL square over 8. But sometimes your beam is more complicated, maybe distributed load, concentrated load, or something like this. So you need to figure it out. Anyway, but your beam will be more simple. Then, design of Berlin. It's looks like a beam, but your vertical distributed load is in vertical direction, but your Berlin itself is inclined with angle theta. So we have two components. These two components will make mx and my. So we have two types of moment, one about x, one about y. So we need to use interaction equation, something like this. M ultimate x divided by design strength about x plus M ultimate y divided by 0.5 design strength about y smaller than or equal 1. You will use all this stuff in your project. Any question? Second one, this one. We need to focus on this file analysis and the design of beam column frame. All of you has frame in your project. Maybe truss alone, frame alone, maybe combine both of them at the same time, truss and frame. Your loading for dead load on weight of your structure, including the frame on weight, Berlin connection, all of this stuff, you can assume your value between 100 to 200 pounds per feet square. Horizontal projection. So I need, this is per unit area. So to convert this value to uniform distributed line load, we need to multiply by distance, which is S. For flexible roof, if you have covering which is flexible roof, corrugated steel sheet, you can assume your load between 25 to 50 pound per unit area. If you have rigid roof, concrete slab, then your value will be your thickness of this slab times 150 gamma of concrete. The two values, the first one is horizontal projection, the second one is inclined projection. So, if you would like to get your dead load as line distributed load, which is horizontal projection, go ahead and use this equation. First value, which is 100 to 200, select something in between, time S, spacing between each main system, plus the second value, which is covering corrugated sheet or slab, time S also, but divided by cosine theta. Your theta is this one. Maybe this angle will not be given, but at least you know what is this height is and what is the total height, or this one. So, and this length.
Yes.
So you can set up a triangle and you can figure out your angle theta. Or maybe it will be given, I don't know. But anyway, and also remember, how can I put my frame in Riza and define horizontal projection? Do you remember how can I define horizontal projection?
PY.
Yeah? Capital Y. Capital Y. Remember, capital Y. Because a small y will make big difference. Okay.
Dr. Raymond, I did have a question. I went in, I was working on recent, I know we said for the, like the global X, we could do, so if I'm looking at that one, at that column, I can
For
say-
wind.
For wind,
Wait,
right.
wait a little.
Okay.
Second load, for live load, we have two cases. Maybe it will not be given if your, based first, what is your angle? If your slope or inclined angle 10 degree or less, go ahead and use this one or this one. If your angle is 10 degree, more than 10 degree, I will use this condition. The first one, if your angle 10 degree or less, maybe we have two situations. The first one, if your roof is axis or not axis. So if your roof is axis, go ahead and use 30 pound per square feet horizontal projection, or 15 if you cannot access your roof. If your degree, maybe 15 degree, your inclined angle 15 degree, what should I do? Go ahead and use this value, 15 minus 0.5 time each degree greater than 10 degree. How many degree over than 10 degree? 5. So the live load to be taken in this case is 15 less 0.5 for each or for every degree increase in slope over 10 degree. So your degree is 15 minus the original angle 10, you have extra 5 degree. Multiply this value by 0.5 and subtracted it from the 15. Your value will be 12.5 pound per square feet. Be sure if your angle may be 25 degree, be sure when you did your calculation, your final value must be equal or greater than 8.5. If you have something here like 7.5, no, go ahead and use 8.5. If you have something here equal 9, go ahead and use 9. If you have something here equal 3.5, no, go ahead and use 8.5. So this value must be 8.5 or greater. Then your live load, which is pound per unit area, go ahead and multiply this value by S. Spacing between each main system, you can get your live load horizontal projection. Then, one more time this exam, how to calculate your wind load. How to calculate your wind load. First step, what is the value of QZ? You are lucky if your average height less than or equal 15. If your average height is less than or equal 15, that means we have QZ one value. Because we have only one value for KZ. KZ will be 0.85 from this table. KZ T1, KD1, V, what is the velocity of the wind, will be given, or you can get it from this link. Anyway, it will be given. So we have one value for KZ, and this value will be the same value for QH also. But if your H may be equal to 25 feet, so we have different value for QZ. The first one from 0 to 15. The second one from 15 to 20. The third one from 20 to 25, or anyway. The last value of your QZ will be QH. Okay? Because QZ and QH will be used in the second equation to get your wind pressure, P. So this one is QZ times G times CB minus QH GCBI. Remember, this equation will be changed a little bit.